Hey guys, going to take a look at one of these Class D type amplifiers. I was down at Parts Express. I live fairly close by, and I can go down to their warehouse showroom and pick up what I need. And I see that they carry a whole bunch of these types of amplifiers. I figured I'd try one out and see how it works. So let me unpack it here and see what we get. Okay, so here's what we get in the package. You get a little input connector cable which plugs into the port here, and here's the amplifier board itself. Seems to be fairly well assembled. No name capacitors. They use these audiophile type film capacitors on the input. I guess they're polypropylene. No name type electrolytics, probably coupling or power supply decoupling or something like that. And output chokes and surface mount capacitors. Seems to be fairly well assembled, but we will test it all out. This uses the TriPath Class T board, chip. TA2024. I was looking at another amplifier. It was $11.80. It was a PAM8610 chip, 2x10 watt. And I went online and looked at the data sheet, and it looked kind of crappy. Even before clipping the distortion at lower wattages or lower power, it was, getting into around 2%. That's just that's pretty ridiculous. So I decided to try this one. TriPath is supposed to have better chips. I guess it's a defunct company now, but somebody else is making their chips, and it's supposed to be, like I say, higher quality. And we will certainly check that out. This board costs $13.80. And gotta forget the power output rating, 2x15 or something like that. The other board, the PAM8610, can only do 8 ohm loads. I'm certain you can probably do 4 ohm loads if you lower the power supply, but this one will do 4 ohm. I'm going to test it out. I'm a little bit concerned. These Class D type amps, they call this Class T, but it's it's just another name for Class D. They are very efficient, but with such a load, 4 ohms, kind of concerned about how hot this chip gets. Heat kills electronics, so I'm gonna test it out, measure it. If it gets too hot, I'm gonna epoxy a little heatsink on there. And like I said, I just want to check this out. I like to build my own amplifiers, but these things are so cheap. Why not just get one and make a video out of it? So, okay, I'm gonna hook it up and check it out and see how it works. Okay, I have it hooked up now. It's connected to my power supply and music player. I'm just using this breadboard as a jumper over to its little input connector and plugged into the speaker down here. Now it does one weird thing, and seems to do it with the music player. Now when I first hook it up, it'll scream real loud. That is loud and annoying. But let me hook the wire up more permanently. Yeah. And quick sample of music.
What is happening and how have you been? Gotta go, but I'll see you again. And the music is so loud.
I can't let that go. That's copyrighted. So It sounds fine. It sounds really clear. I don't hear any distortion or anything. But let me unplug this. And I'll take the power off. See if it screeches. Okay, took the power off. I'm going to hook it up again. It doesn't do it. Huh. So something related to this. None of my other amplifiers do that. Just the weird things with these amplifiers. One of the weird things that never completely happy with them. But anyway, I'm going to hook it up to a stronger power supply and take some output measurements, power output measurements. Okay, I have the non-inductive loads connected, 4 ohms, and have the scope connected to one of the channels, output. And as you can see, it's kind of jittering around a lot. And it's about 900 kilohertz and around 90 millivolts RMS. That's just its operating frequency. Because it's Class D, it's actually running at a very high frequency. And we're just picking some that leaks through to the output. You know, the filters are not going to completely remove that. And it's not going to really, harm the speakers or anything. The inductance of the voice coils of the speakers, it's not going to be an issue at all. Plus the fact that it's way above your hearing anyway. But yeah, I just wanted to check that and go on and do the power test now. Alright, I moved over to this power supply because it'll handle the load, both channels driven with 4 ohm non-inductive resistors as a load here. And I have this set up for 1 kilohertz square wave, or sine wave, I'm sorry. And I'll measure the maximum output here. Let me zoom in on that. So getting 7 volts, 1000 hertz. And this thing gets very hot. Very disappointed in the performance here. Because, wow, it almost burns my finger. Yeah, very disappointing. There's no heatsink on that chip. Even though it's Class D or Class T as they call it, it really needs a heatsink. Okay, as soon as I find my calculator, I will figure the output power. We know it's 49 divided by 4, but I need a calculator for that. So we take our 7 volts, square it, divide it by the load impedance of 4 ohms, we get 12.25 watts. So that's pretty good. It's about what I would expect out of these things. It's about the same you get from those bridged type car amplifiers, the analog type chips. So we're in the same ballpark. But let's take a look at this real quick here. Might be able to get a little bit more, but the way the volume control steps on these things, you see, if I go any higher, then I'm into clipping. But I'm getting these weird, at the top and bottom of the waveform, I'm getting that weird oscillation thing going on. So I'm just not sure if that's the filtering or there's some odd oscillation. So that's kind of odd. And yeah, this thing gets very, very hot. Really needs a heatsink. Now that kind of power, even with Class D, got to have a heatsink. So I would strongly recommend is epoxying a heatsink. Take the sticker off, clean it up, and put a little heatsink on there. It doesn't have to be real big, and just enough to keep the thing cool. It's no wonder these things blow out. A lot of people complain about, not necessarily this one, but a lot of those little Class T or Class D amplifiers burning out. So they don't put a darn heatsink on the thing. So Very, very poor thermal design without the heatsink on there. So, not really going to give this thing a passing grade. So I'll leave it at that and end the video. Thanks for watching.